Hello, this is MEI Further Maths Core Pure. We're in the second vectors section and on the first video on the equation of a plane using the normal to the plane. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. In an earlier video, we saw that the scalar product of any two perpendicular vectors is 0. This is a particularly useful result, and we can use it to define a plane by making use of a vector that is perpendicular to the plane. This may seem a little odd to start with, but once you get used to it, it's really easy to work with. Every plane has a unique direction that is perpendicular to any line that can be drawn in the plane. A vector that is perpendicular to the plane is called its normal vector and is written n. Let's have a look at what this looks like in 3 dimensions. Here we have a normal vector that I'm moving around. You can see the plane, which is the set of all lines which are perpendicular to that normal vector. You can see that that direction is unique for that particular plane. We can use the normal vector of a plane in order to write an equation for that plane in a vector form. Consider the point A in the plane. This is a particular point that we know. We know its position vector A. P is a general point in the plane with coordinates x, y and z and position vector from the origin R. P represents any point on the plane. It's not a fixed point like A. If both A and P lie in the plane, then the line joining them, AP, must also lie in the plane. And that means that the vector r minus a must lie in the plane. This means that the vector n, the normal to the plane, must be perpendicular to the vector r minus a. And so their dot product must be 0. The dot product of r minus a with n is 0. And we can rearrange this using our usual rules of algebra to get r dot n is equal to a dot n. So, if we have a plane with position vector a and normal vector n, a general point r, xi plus yj plus zk, must satisfy the equation r minus a dot n equals 0, which can be rearranged to be r dot n equals a dot n. And this is the most useful form to remember. Let's look at this in practice. Here I have a point A with coordinates 1, 2, 0 and a normal vector to the plane 2i plus 5j plus 3k. I want to find the scalar product form of the plane equation. So I'm going to use this r dot n equals a dot n. So r is what I don't know. R is my general position vector of a point in the plane. So if I dot that with my normal vector 2, 5, 3, I will get the position vector of A, which is 1, 2, 0, also dotted with the normal vector 2, 5, 3. Now I can work out the right hand side of this. 1 times 2 is 2, 2 5s are 10, 0 times 3 is 0, so that's 2 plus 10, which makes 12. So that I've got r dot 253 equals 12. And that's the scalar product form of the equation of this plane. We can use this to solve problems as well. I've got a point 1 minus 3k lying in this plane. So the position vector of that point is 1 minus 3k. And if I dot that position vector r with the normal vector 1 minus 2, 2, I must get the answer 5. So that means that 1 plus 6 plus 2k must be equal to 5. In other words, 2k must be equal to minus 2, and so k is equal to minus 1. There are more notes on integral or in your textbook on finding the equation of a plane using the normal to the plane. That's the end of this short video. The next video in this series is on the equation of a plane in Cartesian form.